Okay, so how about absolute value today? Okay, you guys have seen this before. We'll take it a little step further. All right, the absolute value of a real number, which is x, is written with x in between two bars. It is the distance from 0 on a number line. So if you have the absolute value of x, your answer is going to be positive x. Okay, my absolute value always comes out to be positive. So if I have a negative x inside the bars, it comes out to be positive x all the time. All right, so let's say that whatever was inside here, when we brought it out, it equals 5. That could be negative 5 or positive. Actually, don't write that. It could be negative 5 or positive 5, because either one, when they're in the absolute value bars, when they come out, they become positive. We write that on our number line. That's just a colored in circle. It's not going left or right like last unit. So what this means is that if I have two numbers, let's say I have negative 4 times negative 4, what's my answer? Positive 16, right? Or I could have positive 4 times positive 4 and I get 16. If I have two answers that are the same, they're positive, I don't know if it was two negatives or two positives. That's what we're doing here, okay? Everything, our magic number here is 2. Here's an example. You have a different color pen, or you can use a pencil, it doesn't really matter. I always want you to box up around the absolute value bars. Okay, once you box it up, I want you to see, is it by itself on that side? This is not by itself because there's a positive 3 with it. I need to get rid of that positive 3. How do I do that? Yep, let's subtract 3 from each side. So that means I'm left with absolute value of x is equal to positive 3. Okay, all I did was get rid of that positive 3. All right, step 2 says to get rid of the absolute value bars, set what is inside the absolute value bars equal to the positive and negative number of the other side of the equation. So I draw 2 arrows. I'm going to drop the bars, so I just have x equals 3. I keep the first one the same. All I did here was just drop the bars. For my second equation, I drop the bars and I change my sign. I take the opposite. Is there anything else to solve here? No, it's already an x equals. So this is my answer. You should always have 2 answers for absolute value. So far, so good? Let's look at this next one. I'm going to box up my absolute value and ask myself, is it by itself? The answer is yes. Because it's by itself, I want to get right into my split. I drop my bars and I keep the first answer the same. On the second equation, I drop the bars and I take the opposite. There's nothing else to do here.
So the easier one's by itself.
Yeah, but either way, it's always going to get by itself. Right now it's easy because it's just x. There's nothing else with it. It's going to get harder though. A little bit harder, not much. On your number line, I know you don't have one. Just try to draw one at the very bottom. I forgot to put one on your paper. I have negative 10 and I have positive 10. And so I wobble that in. Your directions tell you to remember to check for extraneous solutions. That means that you could do all your work right, and then you can check your answer and it could be something completely different. Okay? Yeah, it happens all the time. So when we check for solutions, we're just plugging this back into the original. My original would be Let's see here, I got negative 10. If I plug in negative 10 for x, do I get 10 out? Yeah, so this one works. Sorry, that one works. If I have positive 10 and absolute value, does it come out to be positive 10? Yes, so both of those work. Extraneous solution is taking your x and plugging it back in for x to see if it's true. And honestly, I think today, all the extraneous solutions work. All right, let's take a look at number 2. I put a box around my absolute value bars. It's by itself, so I'm going on to step 2, where I split it up. All right, Jeffrey, if I drop the bars, what do I have for my first equation?
18.
Huh?
18. Or 3. X.
3x equals,
18.
well, let's keep the first one the same, negative 18. My second equation is
3x equals
positive 18. Go ahead and solve for x. I'm going to calibrate my board again. Okay, so for my first problem, I divide by 3. What'd you guys get for x? 6? Negative 6. Over here, I divide by 3. So I get positive. What is this board? Every smart board I use is now nuts. Alright, on my number line, I have negative 6, positive 6. If you plug those numbers in, back into your x, both of them work. Negative 6 times 3 gives me negative 18. Bring it outside of the bar. Oh wait, this one doesn't work.
Uh-oh.
Yeah, I didn't even notice that. You guys see that? If we plug this, we're going to check this for a solution. If it's 3 times negative 6 equals negative 18, I get negative 18 equals negative 18. We drop the bars here, we get 18 is equal to negative 18. Does that work?
No.
No. So this one, we can just write EXT for extraneous. The second solution, does that one work? Yeah. 3 times 6 is positive 18.
No.
No, it doesn't work either. They're both extraneous. That's all you have to do though. That just means that we did all the work right. And we got to the end and it didn't work. Because if you think about it, if I have any kind of absolute value, can I ever get a negative number? No. Never, ever, ever. That's kind of a tricky one too, because I guess if you saw that on a test or SOL or something, absolute value, you know it has to be positive. If they give you a negative, you can actually do no work and just say no solution. It doesn't matter what's going on. Nothing out of my absolute value will ever give us a negative number. Okay. Number 3. Absolute value is by itself. So life is good. Eric, what do I do from here?
Bring it down.
Yep, let's split them up. What's my first equation going to be?
2x minus
Equals. And my next equation?
2x.
Good. Guys, we have to remember that anything inside your absolute bars, when you drop the bars, that stays the same. I don't want you guys putting the plus sign here because you think you have to change that sign. You only change the sign after the equal sign. Whatever your answer is, okay? Alright, from here, this part is easy because you guys are good at algebra. What do I do here? Let's add 1 to both sides. So I have 2x is equal to 6. Now what? Divide by 2. So x is equal to 3. My other answer x is equal to negative 2. Right? Not by, oh, sorry, you were step ahead. So 2x equals to negative 4. We divide by 2, and we get negative 2. Any questions on this so far?
No.
check for Schrödinger solutions. 2 times 3 is 6, minus 1, we get 5, that works. Our second is negative, so 2 times negative 2 is negative 4 minus 1. You get negative 5, but absolute value is positive 5. Both of those work. You have a good question? All good on number 3? Alright, here's one that we finally don't have. I don't have absolute value by itself. What is next to it? A negative 9. I need to get rid of it. How do I get rid of negative 9? Yep, add it to both sides. So I still have absolute value. 4 minus 3x is equal to 12. Alright, Jordan, once I get here, I have absolute value by itself now. So what do I do?
Bring the 4 negative 3 down.
Let's go ahead and split them up, right? We drop our bars. 4 minus 3x equals 12. Our other equation is 4 minus 3x equals negative 12.
Negative.
Okay? Let's solve for x here. How do I get rid of that positive 4? Subtract 4 from each side. That cancels, so we have negative 3x is equal to 8. Divide by negative 3. Leave it as a fraction. I'm okay with that. It doesn't matter if your negative goes on the top, on the bottom, or the middle. It's still the same. That's my answer. X equals negative 8 over 3. My other equation, I have minus 4 minus 4. So negative 3x equals negative 16. Divided by negative 3. So x equals, negative and negative becomes a positive, 16 over 3. If you were to check these, they would be right. Okay? Save you some time. All good so far? Let's skip ahead and let's do number 7. And then we're going to let you go on your own. Number 7, my absolute value is not by itself. What needs to leave? That 2, right? That 2 is being multiplied to my absolute value. How do I get rid of a multiplication? Divide it. So we're going to divide both sides by 2 to get rid of it. Guys, if we skip to number 7, you know that? Okay. So we have absolute value of 3x minus 2 is equal to 7. Once I get here, I finally have absolute value by itself. What do I do?
You walk through the box.
What's my first equation?
3x minus 2 equals 7.
Okay, what's my other equation?
3x minus 2 equals negative 7, I think.
Yeah, good job. You just take the opposite. Okay, and now we can just solve. Isaac, how do I get rid of this, or how do I get x by itself?
You minus 2, add 2. And you get 3 minus 9.
Okay. Divide by 3.
And you get 3.
Right, so Once I divide by 3, what's my answer?
3.
Yep. So x equals 3. Good job. My other problem, I add 2. I add 2.
Negative 5.
So 3x equals negative 5. So x is, we just leave it as a fraction. I don't want any decimals. Are you guys getting this stuff?
Yeah.
Pretty easy?
Yeah.
Okay, so I want you guys, okay, so once I split my first equation, I drop the bars, I keep my x, and I keep my answer positive, okay? My second equation, I have 1/2 x plus 3, that doesn't change, and what's my answer gonna be? Negative 7. All right, look at my first equation. First of all, I need how many answers for absolute value? 2. Now go ahead and cross these out.
Here.
It can't just be one answer. Okay? So here I'm going to subtract 3. And I have 1/2 x equals 4. Okay? We're going to multiply each side by what? Not 1/2, flip it. Multiply each side by 2. Okay, so if we do the opposite, that way this cancels out and I have x is equal to 8. Alright, so that's one answer. On the other side, I subtract 3. And I have 1/2 x is equal to negative 10 times 2 on each side. So x equals negative 20. I'm just going to check these really quick. 10 plus 3. So how does that one works? 8. 4. Your answer is D. Questions on what we did today?